Welcome to this video. In this video we will be seeing annealing process. So when steel is exposed to elevated temperatures for some time and then very slowly cooled inside a furnace, we call it as an annealing, and in fact we call it as full annealing. So what happens is, due to the slow cooling, grain growth takes place and average size of the grains are much bigger. So the bigger the grain size, there will be more space available inside the grain for grain dislocations to glide through or climb through. So bigger the grain, there will be much more increased in ductility and toughness. So the main idea is to increase the ductility and toughness of the material. That's why we do annealing. The second category after full annealing is stress relieving. In this, stress are produced by casting, quenching and cold working are removed. So when we have such processes, when quenching, casting and cold working, there is internal stresses developed inside the materials. So after heating it and then cooling it inside the furnace at a temperature of about 0.4 times the melting temperature of the material, so what happens, the grain growth again takes place and the stresses which are inbuilt inside the materials are removed, and we can say that stress relieving process in which this grain size increases and the dislocations can move from one location to other locations because the grain size are bigger and no grain boundaries are in between their motion. So stress are all relieved inside the material. The other category is process annealing. So in process annealing, once we cold work the material, there is a internal stress is built, and if you want to if you want to do further cold work, then it is requiring much more energy and much more work, because material gets hard when we cold work them. So material gets hard and we cannot do further cold work. So to do more cold work, we have to again heat it, and again we have to do the cold work. So when we heat it, it becomes soft. So like after doing process annealing, material again becomes soft for further cold work, and the temperature is below lower critical temperature, which is 727 degrees Celsius. So below 727 degrees Celsius means there is no formation of austenitic structure. We are in the same phase in which the material is, and there is no change in the microstructure, and we heat the material and then again cool it inside the furnace and then do the cold work. In some cases we do cold work parallel after heating the material. When the material is heated, so the material remains soft. The next is spheroidizing. So in spheroidizing, what happens is, when there is a needle like structure inside the material, this is lamination structures we had discussed in iron development of microstructure lecture, and needle structures, the laminations of perlite and cementite is there. So once we do the spheroidized annealing at about temperature cycles above and below 720 degrees Celsius, so what we do, we heat the material above 720 degrees Celsius and then cool it below 720 degrees Celsius and keep it there, and then again heat it and again cool it. So temperature cycle above and below 727 degrees Celsius for some time, and then after that slowly cooling till 600 degrees Celsius and holding it. So there is a grain growth inside the structure, and this needle like structures and laminations of perlite and cementite becomes globular or nodular like structures where it is in spherical form. So the name spheroidized annealing comes from that only. So these needle structures are very much prone to cracking, because from this needle like structure material can easily break because of the stress concentration. So it spheroidized annealing prevents cracking of steel. So when it becomes nodular and spherical in nature, so it is having less stress concentration. So this is done to improve the cracking property, means to prevent from cracking of steels, and this is usually done for high carbon steels. In high carbon steel, there is a cementite present inside the material with the perlite, so it is prone to cracking. So to avoid cracking, we have to do the spheroidize annealing and make it globular from needle, so it is less prone to cracking. So these are the some of the brief ideas about annealing process. We will discuss normalizing, quenching, tempering and diffusion hardening methods in further lectures. Please do subscribe the video and like the video if you have learned something new from it. We will discuss more topics in future lectures. Thank you for watching this video.